Example 1 says one of the wagers in roulette is to place a bet on one of the numbers from 0 to 36, or on, it should actually be from 1 to 36, or on 0 or 00. If that number comes up, the player wins 35 times the amount of the bet and keeps the original bet. Suppose a player bets $1 on a number. What is the player's expectation? Okay, so expected value. There's a couple different ways that we can do this. Let's look at this one way. There's two things that can happen. This player can win money or they can lose money. Okay, so what's the probability that they win? Well, if you remember, on a roulette wheel, there's 38 spaces. The 38 spaces are the numbers 1 through 36. Then you have a 0 and a 00. So the probability of winning would then be 1 over 38. If that's the probability of winning, then the probability of losing has to be the 37 over 38. Okay? If you win, how much do you make? Well, it was a $1 bet, and you get 35 times that amount. So if it's a $1 bet, you would win $35. If you lose that $1, and I made that number negative because it is a loss, okay? I want to go on because a lot of these say what would happen if it was a $2 bet. Well, if it's a $2 bet, then I would win $70. And my loss then would be minus 2. If it was a $5 bet, I would win 5 times 35, 35 times whatever the bet amount is, and I would lose a negative $5 would be that number right there. So just change the amount that you win and the amount that you lose based on the bet, and then what it tells you it is. So it says 35 times. Okay, so let's go ahead and put this into the calculator. Remember, this is a dollar amount. The expected value here is not a probability. This is a dollar amount. So you're going to round your answer to 2 decimal places. And if I put this into my calculator, it looks like I'm getting negative 0.05. So what does that mean? That means remember, all you can do is either win $35 or lose $1. That's your only two options when you go onto this roulette wheel in this bet. It says, on average, if you play this numerous times, you should expect to lose approximately 5 cents for every time you played. So for instance, if you played 100 rolls, if you did this 100 times, you should expect to lose about $5 overall. So how does that work? Well, when you win big. But winning big, $35 is what you would win. And when you lose small. You only lose $1. But what's going to happen is you're going to lose significantly more times than you win. So you'll have one win, and then you'll have 30 or 40 losses. And then you'll have one win, then you'll have 30 or 40 losses. And at the end, that's going to balance out to an average of losing about 5 cents every single time. One thing you'll notice in Las Vegas is there is never ever a bet that you can make, a long-term bets that you can make in Vegas at any of the games that have an expected value that's positive. All expected values on any gambling will be negative. What that negative number means is in the long run, on average, you will lose money. Whether you're playing slots, roulette, craps, gambling, any of the different games in the casino, your expected value is negative. They do that on purpose and only put games there that have negative expected values because that's how they guarantee their profit. Okay, so let's look at example 2 here. It says in a roulette, it is possible to wager one of the numbers between 1 and 12, so that's called the first third, will come up. It says if it does, the player wins twice the amount of the bet. Suppose a player bets $5 on that number, between 1 and 12 will come up. What is the player's expectation? So, again, if we want to know the expected value, we can either win or we can lose. Okay? So if we win, well, let's look at the probability of winning. The probability of winning here, we're betting on the numbers 1 through 12. So we have 12 opportunities to win. And again, in a roulette wheel, there's 38 total spaces. So if 12 over 38 is what it is that I can win, all the remaining is the probability that I lose. So 38 minus 12, that's 26. So that'd be 26 out of 38 spaces I would lose. 12 of the 38 I'd win, 26 out of the 38 I'd lose. If I win, let's see what it is. I'm betting $5 and I win twice as much. So if I'm betting $5 and I win twice as much, that would mean I would win $10. And if I'm betting $5 and I lose, then I lose that $5. Again, the 10 is positive because it's a win. The 5 is negative because it's a loss. Go ahead and put that into your calculator and see what you get. My expected value here that I'm getting is negative, about rounded to the nearest cent, about 26 cents. So what should I expect? If I kept on doing this bet on average, if I did this bet many times, I'd lose approximately 26 cents every single time I made that bet. So 26 cents times the number of bets that I made. Again, this is not possible to happen in one turn. This is on average in the long run. Okay. So why do we care about expectation? Well, expectation, whether you know it or not, truly runs your life. Every single one of you has to carry insurance. Health insurance is legally required now in the United States. Car insurance is legally required to drive. Fire insurance is legally required to hold a mortgage on a house. Insurance on everything. There's health, all different types of insurance throughout your life. I can't tell you how many different types of insurance that you're going to be paying. So how do they determine how much you pay for that insurance? Well, what they do is they have these people called actuaries, and the actuaries are statisticians who look at the data. So for instance, if you're, let's say, a 25-year-old male, and they'll get more qualifications on you too, but let's say a 25-year-old male who wants car insurance. What they'll do is they'll look at what's the data, what's the expected value, or what's the probability that someone who's a 25-year-old male gets in a wreck. And if they get in a wreck, how much is it going to cost them? And so they look at the data and they look at the probabilities, and then they set the insurance rate, your insurance premium, whatever you pay monthly, to ensure that they're collecting enough money to cover their butts in case you get in that wreck. They have the probabilities that you'll get in the wreck, so they create these prices for insurance based off of these probabilities that you're going to get in a wreck. Again, what do? They look at the expected value, and they make sure the expected value for you is negative and the expected value for them is positive. They want to make sure in the long run they're going to make money. So let's look at one of these situations. It's pretty morbid, but that's just truly how this works. It says, according to the mortality tables published in the National Vital Statistics Report, a probability that a 21-year-old will die within 1 year is approximately 0.000962, so a very low probability they die. It says, suppose that the premium for a 1-year $25,000 life insurance policy for a 21-year-old is $32. What is the insurance company's expectation for this policy? So this is the insurance company's expectation, so we're looking at it from their point of view. Okay, so there's a couple of ways of doing this probability, and I'm going to have you guys look at this, and it may or may not, one of these two ways hopefully work for you. Okay, so let's think about it. If we're looking at the expected value, we can look at what's going to happen. Our possible outcomes is the 21-year-old lives or the 21-year-old dies. So, what happens if the 21-year-old lives? Well, first of all, let's look at the probabilities, because remember, you're going to do probabilities times the expectations. So what's the probability that they die? The probability they die is very, very low. So that's 0.000962. So what's the probability that they live? Well, the probability that they live is 1 minus that number. So do that in your calculator. I'm going to do 1 minus 0.000962. So the probability that they live by doing 1 minus that number is 0.999038. So there's the probability they live and the probability they die. Okay. Remember, we're considering this from the insurance company's point of view. So if this person lives, what happened to the company? Well, if the person lives, the insurance company paid out nothing, and they got that premium. The premium was $32, so that means the company made $32 and didn't have to pay out a cent for them, okay? Now let's consider what happens if that person dies. If that person dies, which is a very low probability, but if they die, that insurance company needs to pay out that $25,000. So really what this is you're going to have that negative $25,000 because that's them losing $25,000. But there's one little caveat here. You have to add in the $32 because that person did pay a positive $32 for the premium. So technically what you're looking at here is the company really lost $25,000 minus the $32 that they paid for the premium, which is $24,968 loss. That's what that number really is in there. So they didn't lose the full $25,000. So go ahead and put that into your calculator and let's see what you guys are getting. Again, this is dollars. We're talking about money here. So the money that I'm seeing here is about $7.94, and it's a positive number. So what does that mean? That means for every single plan this insurance company sells, they should expect an average of $7.94 profit. So what would it be if they sold this to 1,000,000 21-year-olds? Well, they would make nearly $8 million profit that year. So what's been happening lately is insurance companies have been jacking up rates so much that their expected value is increasing ridiculously high, and these insurance companies are profiting millions and millions, if not billions, it's actually truly billions of dollars every single year. They choose the rates that you pay, and it really kind of sucks because you have no option of getting insurance or not. You are legally required to have insurance, and all they have to do is say, hey, instead of you paying $100 a month for your car insurance, you're going to pay $300 a month for car insurance, and if you don't have car insurance, you can't drive. So, really, really crappy that they do that, but this is the math that they use. They use the probabilities from things like the National Vital Statistics Report. They determine what should they charge you, and they always make sure their inspected value is positive. Okay. Sorry, let me correct that amount. I actually got $7.95 when I did this. I'm going to come in here and change that to $7.95. Okay. So this is using the expected value formula as we've used it before, but I told you that I was going to do it a second way. There is an easier way to do it on these life insurance probabilities. So what you notice with probabilities is when you add the two probabilities together, win and die, or if there was more probabilities, those numbers theoretically should always add to 1. The following way that I'm going to show you, the probabilities will not add to 1. So this is not the official way of doing it. This is not the formula way, but this is an easier way of doing it. So here's what I think of. We are now the insurance company. What happens? There is a probability of 100% guaranteed, that every single person pays $32. So every single person pays $32. That's a $32 profit for every person, a probability of 1. And then they have a loss, so I'm going to put subtraction here, and now I'm going to do the probability that they die, which was the 0.000962 times the amount that they have to pay out if they die, and that was the $25,000. If you do this into your calculator, you're going to get the exact same thing of $7.95. So again, this one is because everyone has to pay. Here is the cost of the premium. Here is the probability they die. And then here is the loss. Make sure you use the subtraction sign. So if you want to do this method instead, it's way, way, way easier or faster. To me, it is anyways. But if you want to do it the official formula way, where your probabilities add to 1, you need to do it the first way. Hope that helps.